Okie dokie. So here's some review problems. The first one, we have a distributed property on the right, and we're also going to wind up with variables on both sides. And the next three are, again, percentage problems. And this time, I'm going to just strictly focus on the shortcuts. Okay? So usually when the percentage problems are reviewed in the beginning of the year, I do that thoroughly, right? And so now we've come to the point in time where I'll show you the shortcuts, which is what I actually do myself, okay? All right, well, this first problem, just so you know, if you want to chat me a solution, I'll tell you if it's right. Okay, there's a good bit of things going on here. Correct, Jorge? And the mistakes that people make tend to be reacting to what they see instead of interpreting the problem as big picture. So you might look at this and go, oh, 22 minus 5. And then put this as 17. Oops, that pen is not going to work. Put this as 17 times. That is incorrect, because this 5 next parentheses implies multiplication. You cannot subtract from a multiplied number, right? So think of it like this. If this was 22 minus 5 times 3, you got to do the 5 times 3 first. You can't subtract 22 minus 5, right? Because this would be 22 minus 15. If you subtract from the 5 first, then you're doing this out of order. And we call these order of operations, right? So we should do multiplication before we do addition. Now, PEMDAS is what people call this: parentheses, exponents, multiplication, division, addition, subtraction. Some people call this, please excuse my dear Aunt Sally. Right, give me a second, y'all. I'd make an adjustment here, and I will go. So that's how I always learned this, was the please excuse my dear Aunt Sally method. And the problem with thinking of this as always in order is that there's some little glitches with this. All right, and here's a particular glitch. Now, there was an internet controversy, and students would sometimes ask me what this is. Well, if you follow the order of operations, it says multiply before division. So you might do 6 times 2 first. Actually, if you don't have any addition or subtraction, and there's no exponents and no parentheses, you go left to right. So we actually should divide by 6 first and then times 2. Here's why. Remember, when you divide, you multiply the reciprocal? So if we change this all into multiplication, notice you got to do the 30 times 2, and then you divide by the 6. Okay? So be careful, because sometimes if you have issues like that, the order isn't perfected. It's not a written stone kind of rule of law. It depends upon how the operations are organized in the overall problem. Just one, yeah, let me throw that away. All right, so finishing this, I'm not going to do the whole way. So we want to do the distributed property first. Okay. And so this is going to become negative 15x. Now be careful, because you're looking at a minus here, so you might want to write minus, but that's a minus 5 and minus 2, so you should be getting a positive 10. All right, and then we can simplify. Okay, and then you just finish that. I would add 15 to both sides, and then you'll get the variable term over here, and then add 11 to the 32. And then you'll be able to divide by the number multiplied to x, and what you should be getting is 43 over 21. Okay, which would be, if you wrote this as a mixed number, the closest multiple of 21 is 42, so that's 2 wholes, and you got 1 leftover piece. Okay, and that would probably be around 2.04, probably 2.047 or something like that. Okay, now the last 3 problems. So you can look at number 2, and you can think of this as writing an equation. What number is, so something you don't know, equals 35% of 150. So the of you can change to multiplication, and so you could write the equation x equals 0.35 times 150, and then just solve that. Now here's how I do this, okay? If I know I'm multiplying these, then it's just figuring out how to get the percentage out of 150. So if you divide by 10, that's 10%. So 15 is 10%, and we have 30 plus another 5%. Well, okay, well half of 10% is 5%. So we need 3 15s, and then we'll add a 7.5. So 3 times 15 plus 7.5. That's how you can do the mental math. Or you could just multiply that. Now notice I changed this to a decimal, right? Because when we changed the 35% to a decimal, it's now per 1. So for every 1, we're going to get 0.35, and we have 150 ones. Whereas if we had it this way, that would mean per 100. Changing it to decimal is more convenient when you're doing the multiplication, because essentially you're making this to become the decimal per 1. Okay? And so let's see, Jorge, you got that correct too? Okay, so here, this is just like getting a grade on a test. Okay? Which is something that would be a good idea to know how to do, right? So 18 out of 24. Now, some of us, we have our little procedures, and that's fine if they work. But if you're not able to get the percentage from number 3, then your method is not working, all right? Because you just divide these numbers. And when you're doing that, you're really solving this problem, right? So your procedures may work, but if they're not working, let's figure out something that does work so you can always get the answer right, all right? So this is really what you're doing when you solve this problem. If this is out of 24, what would it be out of 100? We call that a percentage. We convert the score on the test, which was out of 24 points, to out of 100 points. That's really what we're doing. This is really a proportion. So when you go ahead and you divide this, in this case you could simplify it, because they're both multiples of 6. So 3/4. And now that's a lot easier if you had to cross multiply. If you divide 3 by 4, you get 0.75. Right? So the reason we move the decimal 2 places is because notice when we cross multiply. You could also think of it as, let's multiply top and bottom by 100 to get this per 100. Okay, 75%. So if you got 18 correct out of 24 points, you get 75%. And we write it this way because we want to imply that this is a rate. It's not 75, it's 75 per 100. That's why we put this percent symbol there. Okay? Now the way I score you guys' quizzes, right, this is the reason I do it that way, because I just take this and move the decimal 1 place. So I make it per 10. I can do that in my head, easy. That's why I make it out of 10, it's easy. Okay, so we get the points and then we convert it. Same thing here. All right, now the last problem. Now, last problem's a little more wordy than number 2, right? Number 2 was very brief. Number 4 has 3 sentences. And notice this first sentence is giving you a number, and then the second sentence starts with the word this. This is a demonstrative pronoun. It is demonstrating what that word means in a previous location. That's what this means. We are demonstrating that this number 1200 is what this refers to. Okay? So that actually means from the second sentence, 1200 is, so 1200 equals 30% of your total monthly salary, which you don't know. So number 2 and number 4 are kind of the reverse of each other. Here you have the percentage times the unknown quantity. So 30% of your total salary only goes to rent. So this is not your total salary. You're making more than $1,200. This is just your rent. 30% of that unknown total salary goes to rent. All right, so this is where you divide by the percentage. Again, this is the shortcut. So if that works better for you, by all means. All right, now we divide. Okay, and then you could use a calculator, but let me show you a little trick, a little tricky route. This is really 12 times 100. Right? And now I'm going to move the decimal to make this 3. You can't just magically do that. So now I'm going to multiply top and bottom by 10. Now I do this all in my head, by the way. All right? So this becomes 120 over 3. 120 over 3, and then you times 100. Okay, well that's easier to do now. That's 40. 40 times 100. Well, 40, and then add 2 more zeros. So that's the mental math. Right? And see what you can do when you understand fractions. Look at all these tricks you can do. So I'd just look at this and I'd be able to go right there. Of course, I'm 51 years old, right?